Hello. Are you guys there?
Yeah.
Yeah, you were asking me why they divided by 60. Because जितना atomic mass unit होता है उतने grams will have Avogadro number of atoms, right?
Yeah.
You had said 1 gram में जितने होते हैं 1 gram में नहीं होते, otherwise हर atom हर element will have same number of atoms in each gram, तो सबका mass same ही रहेगा ना, फिर density भी same रहेगी. वैसा नहीं होता, जितना उसका atomic mass unit होता है उतने grams will have Avogadro number of atoms.
नहीं समझा.
यार एवोगैड्रो नंबर क्या होता है?
Number of atoms in one mole or something with mole also is there. Mole, right?
हाँ.
Yeah.
तो मोल कब होएगा? एक मोल कब होएगा?
When there are 6.0 to 3
वही बता दिया ना, उल्टा ही घुमा दिया. I'm saying एक मोल कब होएगा? कितने में होएगा? जब उसके एटॉमिक मास यूनिट के बराबर के ग्राम्स होंगे तब उतने मोल होते हैं ना.
Yeah, 1 EMU ना.
तो यहाँ पे अगर इसका एटॉमिक मास है 62.92 यूनिट्स, तो 62.92 ग्राम्स में एवोगैड्रो नंबर ऑफ एटम्स होंगे. बिकॉज इसका 1 मोल
कितने एटम्स होंगे?
हाँ, क्योंकि इसका 1 मोल बनेगा 62.92 ग्राम्स पे, राइट?
Yes, understood.
ओके. तो 1 ग्राम में इतना होएगा, 63 ग्राम्स में इतने एटम्स होंगे, तो 1 ग्राम में इतना बाय 63 होगा, तो 3 ग्राम में इतना बाय 63 इंटू 3 होगा. तो यहाँ से नंबर ऑफ एटम्स आ गया. तो टोटल मास डिफेक्ट ऑफ ऑल एटम्स, एक एटम में कितना मास डिफेक्ट है इनटू कितने एटम्स है, तो इतना आ गया. अब इतने की एनर्जी कितनी होगी, तो उसको सी स्क्वायर से मल्टीप्लाई कर देंगे तो आ जाएगा. करो उसको खुद से, वापस से देख के खुद से करो उस पूरे क्वेश्चन को.
Instead of I got till the end, but they multiplied into 931. What is that? I just did into 3 into 10 raised to 3 into 10 raised to 8 ka whole square.
Yeah, you do that only. कर लिया?
So I didn't understand the 931.
You don't have to. It's the conversion of joules to MeV.
So just directly C square.
Yeah. Done?
What do you get the final answers after that with C square?
जो भी आ रहा
You'll
है,
get
you should just understand the process of calculating this.
What is 931
अभी
MeV?
बताया ना भाई, जूल्स से कन्वर्जन है, अभी तो बताया.
Oh, I missed it. Sorry.
वीडियो किधर तुम्हारा? आगे बढ़े. Shall we move ahead? आगे बढ़े, हो गया? ओके. See, 1 AMU equals to 931 MeV per C square. So एक AMU को C square से मल्टीप्लाई करोगे तो इतनी एनर्जी आएगी. That's what 931 MeV is. Okay. Anyway, चलो आगे बढ़ते हैं. Binding energy curve. It's a plot of binding energy per nucleon versus the mass number A for a large number of nuclei. इसको ड्रॉ कर लो. So जैसे जैसे मास नंबर बढ़ते आता है, बाइंडिंग एनर्जी पर न्यूक्लियन increases and becomes stable.
We have to learn this graph.
हाँ, just in case it comes in the exam कि इन चारों में से कौन सा सही है. चलो पहले फीचर देख लेते हैं. The following are the features of the plot. The average binding energy per nucleon for lighter nuclei like 1H1, 1H2, 1H3 small. ठीक है, इधर small है. For mass numbers ranging from 2 to 20, there are sharply defined peaks corresponding to 2He4, 6, C12, 8, O16, etc. है ना, इनके sharp curves हैं He4, C12, O16, फटाक से बड़ा उधर. The peaks indicate that these nuclei are relatively more stable than the other nuclei in their neighborhood. ये भी अच्छा पॉइंट है कि अगर बाइंडिंग एनर्जी पर न्यूक्लियाई ज्यादा है, न्यूक्लियॉन ज्यादा है, इसका मतलब वो ज्यादा स्टेबल है, क्योंकि उतनी एनर्जी चाहिए उनको तोड़ने के लिए, है ना. सो दैट कुड आल्सो बी अ क्वेश्चन कि जिसका बाइंडिंग एनर्जी ज्यादा है वो ज्यादा स्टेबल है कि कम स्टेबल है. वो ज्यादा स्टेबल होगा. Binding energy curve has a broad maximum peak in the range of A equals to 30 to A equals to 120. A equals to 30 से लेके A equals to 120 तक ये पीक चल रहा है. उसके बाद कम होना शुरू होता है, तो इसका मतलब ये कम स्टेबल है ना. Which is practically constant corresponding to average binding energy per nucleon is 8.8 MeV. As the mass number increases, the binding energy per nucleon decreases gradually, falling to about 7.6 MeV per nucleon for blah. The decrease may be due to Coulomb repulsion between the protons. The heavy nuclei are therefore relatively less stable. So good. ये ग्राफ भी बनाया प्लस इनका फीचर्स भी है, तो ये नोट कर सकते हो. ग्राफ ऐसे ही नोट कर लो और समझ जाओ कि क्या मतलब है इसका. तो शुरुआत में ये अनस्टेबल होने चाहिए, इनको बहुत जल्दी हम तोड़ सकते हैं 1H और 3H, 1H 2H 3H के लिए. उसके बाद हीलियम, कार्बन, ऑक्सीजन, ये बहुत स्टेबल है एज कंपेयर टू ये उनके काउंटर पार्ट इधर. उसके बाद ये आगे बहुत स्टेबल है. उसके बाद बाकी कम होते हैं. वो कम इसलिए होते हैं बिकॉज उनका रिपल्शन हो सकता है, जो प्रोटॉन्स उनके रिपल्शन के कारण उनकी बाइंडिंग एनर्जी कम हो गई, जिसके कारण वो कम स्टेबल. ठीक है. और आगे बढ़े, किसको भी नोट करोगे? Okay, done. Okay. When very heavy nucleus has lower binding energy compared to that of the nucleus A equals 120. Thus, if a nucleus 240 breaks into two 120 nuclei, nucleons get more tightly bound. Energy would be released in this process, nuclear fission. तो अगर बड़े न्यूक्लियस टूटेंगे तो न्यूक्लियर फिजन होगा, तो वहां पे रिलीज होगी एनर्जी. When two light nuclei join to form a heavier nucleus, वहां पे भी एनर्जी निकलेगी, क्योंकि यहाँ पे देखो ये अगर इस पार्ट वाले अगर ये फ्यूज होते हैं, फ्यूज होंगे तो बड़ा न्यूक्लियस बनेगा, तो उसकी ज्यादा बाइंडिंग एनर्जी है, तो एनर्जी रिलीज होगी उस प्रोसेस. सिमिलरली यहाँ पे टूटेंगे तो भी एनर्जी रिलीज होगी, इसलिए इनकी बाइंडिंग एनर्जी फिर यहाँ पे पहुंचेंगे ज्यादा स्टेबल है. ठीक है, खत्म हो गया यहाँ के. Nuclear stability. The stability of a nucleus is determined by the value of its binding energy per nucleon. The higher the binding energy, more stable is the nucleus. The stability of nucleus is also determined by its neutron to proton ratio. A plot of the number of neutrons and number of protons is shown in the figure below. The solid line shows the nuclei with equal number of protons. Only light nuclei are on this line. That is, they are stable. If they contain approximately same number of protons and neutrons, that is, they are stable. यहाँ पे सेम नंबर होएगा, ऐसा है. शुरुआत में सेम होते हैं, बट धीरे धीरे वो डिफ्लेक्ट करने लगते हैं. Heavy nuclei are stable only when they have more neutrons than protons. तो ज्यादा न्यूट्रॉन होगा, कम प्रोटॉन होगा, तो वो स्टेबल होंगे. द लॉन्ग नैरो रीजन शोन इन द फिगर which contains a cluster of short lines representing stable nuclei is referred to as the value of stability. Cool.
So how much left?
ये लास्ट पेज है. न्यूक्लियर फोर्स.
इधर last page है, page 5 और 36.
बट आगे तो वो है ना,
That is cancelled.
That is cancelled, no? DK वगैरह.
the force must be so strong to overcome the repulsion between protons and to bind both protons and neutrons into a tiny nuclear volume. The constancy of binding energy per nucleon is a consequence of the fact that nuclear force is short ranged. From the plot, it is concluded that potential energy is minimum at distance r0, which is equals to 0.8 FM. What is FM?
Fermi meter.
What is Fermi?
A
Minus
small
15.
अरे वो Fermi 10 to the power कितना
Raised to minus 15.
minus 50.
10 to the power minus 15. ठीक है. ओके, सो 0.8 के आसपास वहां पे पोटेंशियल एनर्जी मिनिमम है, which means the force is attractive for distances larger than 0.8 and repulsive for distances less than 0.8 between nucleons. Some of the important characteristics for these forces are as given below. Nuclear forces among a pair of neutrons, a pair of protons, and also between a neutron proton pair is approximately the same. Nuclear forces same होते हैं in pairs के बीच. This shows that the nuclear forces are independent of charge. Second, the nuclear forces are very short range forces. They are operative up to distances of the order of few Fermi. ठीक है. The nuclear force is much stronger than the Coulomb force. Okay. Nuclear force between two nucleons falls rapidly to zero as their distance is more than few femtometers, FM. This leads to saturation of forces in a medium or large size nucleus. That is, each nucleon interacts with its immediate neighbors only, rather than with all the other nucleons.
What is femtometer?
Should be the same as Fermi. Femtometers. Femtometers. 10 to the power minus 50. Cool. The nuclear forces are dependent on spin or angular momentum of nuclei. Okay. ठीक है, यहाँ से हो गया खत्म. अगली क्लास में we'll try to do some questions on this chapter and the chapter on atoms. हालांकि I would suggest that do the chapter on atoms वाले questions. उसके फॉर्मूले तुम्हें याद रहेंगे. बाद में ये चैप्टर का हम लोग थोड़े बहुत क्वेश्चंस कर लेंगे. रेडियो एक्टिविटी नहीं है ना पक्का?
No.
ठीक है. Cool then. Long class.
Okay. Thank you, sir. Bye-bye.
You want some jokes? You want to laugh? Should I ask some questions to Sanskriti?
Should we ask the door one?
संस्कृति को सुनाई नहीं दे रहा.
Her voice is breaking a lot. Bitna even got disconnected.
Okay. All right. ठीक है. Fine. Have fun. Take care. Bye bye.
Sir,
Yes, sir.
tomorrow in the schedule it's written magnetism and matter
Okay.
class. I was asking, can we do ray optics and optical instruments, because I have exams from 19th and that chapter is coming.
Okay.
And we have from
We
21st.
also have
21st.
21st and we also have magnetism and matter.
Okay. Okay. Let me think.
How many classes will ray optics take?
Yeah.
Ray optics is easy if you have done it properly in your grade 10.
Yeah.
You should take one class. Same
And
with
magnetism.
magnetism and matter. Same.
Okay, then
Magnetism is not that much. We did
Yeah.
nothing. The derivations aren't there, right, anymore. So
Yeah.
now
If
it's only theory.
ray optics.
We have dia,
Yeah,
para, that all.
Yeah, but usme there's no enough explanation or
Yeah, there's
anything.
no-
That we have to
yeah, there's no
learn anyway.
What I really like is that you guys are on top of things. So that's good. You already know what is there in syllabus. You already know what is to be done. अच्छा है, ऐसे बच्चों को पढ़ाने में अच्छा लगता है. ना पीछे नहीं पढ़ना. Good. Awesome. Fine. So tomorrow we'll see. We'll play by the ear. We'll try to finish 1.5 chapters. So we'll do some out of magnetism. खत्म कर देंगे इसको. Then we'll start with ray optics. Ray optics and what did you say? हाँ, वो जो instruments वाला है वो थोड़ा लंबा हो सकता है.
It's one chapter only. Continuation ही है optical instrument.
हाँ, और जो instruments वाला उसमें थोड़ा सा क्योंकि हर instrument के बारे में पढ़ना पड़ेगा तुम्हें.
Yes, there are cases now for the magnifying and everything.
Yeah. When's your exam?
19th onwards is beginning, but we don't have the timetable yet.
19 September.
Yes.
What time? और इस पोदार में
21st. And also magnetism and matter, they don't know for sure if it'll be asked in this exam. And we're doing the electromagnetic base wala chapter now in
Sir, I have magnetism and matter in my half yearly.
when is your half yearly?
So practicals are starting from 15 and written exam I guess they're from 20.
तो टाइम है ना अभी. बट इस चैप्टर को छोड़ के भी बाकी चैप्टर भी प्रिपेयर करो. तुमको तो बहुत प्रिपेयर करना है. प्रैक्टिस करो. I was saying something. Okay, I forgot. ठीक है, fine. So ठीक है, इसको कंप्लीट करते हैं फिर. अभी तो टाइम है. We'll finish the chapters. Then let's focus on practice. All right, okay. Take care. Bye bye.
One more thing, some maths class.
क्या math class?
What like when they scheduled this week also there's
You
no
have to
maths
ask
class.
last time. Scheduling वाला last time.
Okay.
ठीक है. Bye.
Thank you, sir.